Hey guys, today I'm going to introduce you 5G standards related to remote drone ID. The third generation partnership project, 3GPP, is an umbrella term for a number of standards organizations which develop protocols for mobile telecommunications. 3GPP is a consortium with 7 national or regional telecommunication standards organizations as primary members and variety of other organizations as associate members. 3GPP specification work is done in technical specification groups and working groups. There are 3 technical specification groups, each of which consists of multiple working groups: Radio Access Network, RAN, Service and System Aspects, SA, Core Network and Terminals, CT. 3GPP standards are structured as releases. 3GPP follows a 3-stage methodology. Stage 1 specifications define the service requirements from the user point of view. Stage 2 specifications define an architecture to support the service requirements. Stage 3 specification define an implementation of architecture by specifying protocols in detail. Before review of 3GPP standards related to unmanned aircraft vehicle, I'd like to introduce one of the key features of 5G network, which is 5G verticals and slicing. Previous generation of cellular network were targeted to human communications in the form of voice, data, and internet, and had the only architectural principle: one fits all. 5G network adds industrial communications feature to help digitize the economy and contribute towards global digital transformation. The concept of slicing allows businesses to control cellular network resources on a flexible and granular level, optimizing resources for the specific business. But this requires additional work for mobile operators. So, to make business solution interoperable and reduce cost of creating specific mobile networks, 3GPP creates specifications for adapting mobile network for the specific businesses. Mobile operators deploy those specific networks using concept of slicing. In our case, Release 17 and 18 published a set of documents related to UAV, UTM, and U-Space support. I will stop on 2 of them: Uncrewed Aerial System support in 3GPP and Uncrewed Aerial System connectivity, identification, and tracking. The first one defines requirements and supporting UAV in 3GPP. The second one describes architectural model and concept to satisfy requirements. Other documents describe changes in core elements of 5G related to UAV support. They are more specific and intended for engineers and manufacturers of 5G equipment. This slide shows assumptions and use cases taken for their requirements. You see that 3GPP network is intermediary between UAS and UTM. It provides connectivity between UAV, UTM, and UAV controllers. Taking in consideration country-specific policies and international standards, 3GPP defined a set of requirements for 5G mobile network which supports UAV-related businesses. The requirements are separated in three groups. They are remote identification, UAS usage, and performance. Remote identification of UAS requirements subdivided in general and traffic management. UAS usage are subdivided in general, exposure UAV services, service restrictions, requirements for onboard radio access node, and C2 communication. Performance requirements are subdivided in KPI for services provided to UAV applications, KPI for UAV command and control, position and performance requirements, and other requirements. General concept of architecture enhancements is described in Technical Specification 23.256. It includes 5G support for authentication and authorization of UAV with the UAS service supplier, USS in short. Support for USS authorization of C2 communication and reference model for UAV tracking. 5G will also support geofencing and geocaching functionality in USS by providing location services and event notifications to subscribed USS. Logical UAV reference architecture shows data flow between UAV and USS. UAV sends data to Next Generation Radio Access Network, which communicates with 5G Core. 5G Core communicates with USS through UAS-NF, which is Unmanned Aircraft System Network Function Element. 5GS non-roaming reference architecture shows existing, new, and modified components and interaction between them. Access and Mobility Function, AMF, Session Management Function, SMF, and Network Exposure Function are modified, and UAS-NF is a new function element. Roaming reference architecture has similar changes. This table shows detailed description of new and modified elements. UAS-NF is used for external exposure of services to the USS. UAS-NF makes use of existing exposure services for UAV authentication authorization, flight authorization, UAV controller pairing authorization, and related reauthentication, reauthorization, and revocation. It also used for location reporting, presence monitoring, obtaining list of aerial user equipments in geographic area, and control quality of service traffic filtering for C2 communication. UAV must have CAA level UAV ID, as known as Drone Remote ID. UAV that hasn't performed a registration with Aviation Administration shall not attempt to request for UAS services. In addition to existing functionality, Access and Mobility Management Function, AMF, may trigger USS UAV authorization authentication procedure in 5G core by USS when required. Session Management Function (SMF) will trigger the USS UAV authentication authorization at PDN connection PDU session establishment procedure for user equipment required UAV authentication and authorization by USS. It also may trigger authorization of pairing between UAV and networked UAV controller. Architectural model works with two identities. The first one is CAA level UAV identity, Civil Aviation Administration level. It's also known as Remote Drone ID in terms of ASTM. And the second one is 3GPP UAV ID. Generic Public Subscription Identifier GPSI in short, in the format of external identifier is used as the 3GPP UAV ID. Association between GPSI and Remote Drone ID is stored in UAS Service Supplier. UAV authentication and authorization includes three procedures. UAV USS authentication and authorization procedure, UUAA in short, is performed to be sure that UAV has successfully registered with USS and has therefore been authorized for operations by the USS. UUAA-MM is a UAV USS authentication and authorization procedure optionally performed during registration to 5GS. UUAA-SM is UAV USS authentication and authorization procedure performed during establishment of a PDU connection. To register UAV in 5G, UAV must pass 3GPP UAV ID and optional drone remote ID. If policy requires authentication and authorization of UAV in USS during registration, 5G will run UUAA-MM procedure to exchange authentication authorization messages between UAV and USS. When UAV sends session establishment request with USS, it provides 3GPP UAV ID and CAA UAV ID to 5G. 5G will run UUAA-SM procedure to exchange authentication authorization messages between UAV and USS. When UAV sends session establishment request with C2, it provides 3GPP UAV ID, CAA UAV ID, and pairing info to 5G. 5G will communicate with USS, and USS will authorize 5G with establishing session between UAV and C2. UAS and F, together with 5G core, will also serve as a bridge between USS and UAV during recertification, reauthorization, revocation, location reporting, and other requests from USS. When USS or third-party authorized entity subscribes for UAV tracking, UAS and F will provide reporting by communicating with Gateway Mobile Location Center and Access and Mobility Management Function. The architecture supports three tracking modes: UAV Location Reporting Mode, UAV Presence Monitoring Mode, and list of aerial user equipments in geographic area. That is it. Thank you for watching this video. I would be happy if you share this video with your colleagues and put like on it. Goodbye.